Have you ever wondered what else, apart from us, might be out there in the universe, living, breathing, existing in ways we can't even imagine? Today, we're diving into the enigma of life, but not as we know it. We're familiar with life on Earth, carbon-based life forms like us humans, animals, even plants. But could there be more to life than carbon? Scientists speculate that life might exist in forms that are alien to us based on other elements. Silicon, for instance, is one such candidate. Silicon atoms, like carbon, can create molecules that are large and complex enough to carry biological information. Yet this is just the tip of the speculative iceberg. Life could potentially exist in extreme environments, too hot, too cold, or too hostile for carbon-based life forms. So if we're open to the idea, life could exist in forms that are exotic and beyond our wildest imaginations. Let's delve deeper into the concept of silicon-based life. Why silicon, you ask? Well, there's more to this element than meets the eye. Silicon, like carbon, belongs to the same group in the periodic table, known as Group 4. This means that, similar to carbon, silicon has 4 electrons in its outer shell, enabling it to form strong, stable bonds with other elements. This is a crucial property for the building blocks of life as we know it. But why is life on Earth carbon-based and not silicon-based? The answer lies in chemistry. Carbon can form an array of complex, stable, long-chain molecules which are crucial for life. Silicon, on the other hand, while also capable of forming complex structures, is less versatile. Silicon compounds tend to be less stable, especially in the presence of water, which is considered an essential ingredient for life. However, if we dare to think outside the box, we can imagine a different scenario. In extremely cold environments where water is solid and chemical reactions occur at a much slower pace, silicon-based life could theoretically exist. These life forms might not resemble anything we know, but remember, we are trying to stretch our understanding of what life could be. But it's not all smooth sailing for silicon-based life. One of the primary challenges would be energy production. In carbon-based life, energy is generated through the reaction of carbon with oxygen, a process called oxidation. Silicon, however, binds with oxygen to form sand, a process that releases much less energy. This could limit the complexity and activity of potential silicon-based organisms. Despite these challenges, the idea of silicon-based life has not been entirely ruled out. It's a tantalizing prospect, especially when considering the search for extraterrestrial life. Silicon is abundant in the universe, so who knows what exotic forms of life may be lurking out there. Though silicon-based life forms are purely speculative at this point, it's a fascinating concept that broadens our understanding of what life could potentially be. But what about life in conditions that would be extreme for us? Could life thrive there? Cue extremophiles, these resilient organisms that call Earth's harshest environments home. From the scorching heat of volcanic vents to the freezing cold of the Antarctic ice, these organisms have adapted to survive and even thrive. They're living proof that life can exist in conditions far removed from what we consider normal. Consider the tardigrade, also known as the water bear. This microscopic creature can survive the vacuum of space and the deepest ocean trenches. Then there's the Pompeii worm that thrives in the extreme heat of hydrothermal vents, and the halophiles that love the salt-saturated waters of the Dead Sea. These extremophiles could be our best clue yet to understanding how life could exist in the harsh conditions of other planets or moons. If life can thrive in Earth's extremes, who's to say it can't exist in the harsh conditions of other planets or moons? The universe is vast and diverse, filled with a plethora of elements and conditions. Who knows what exotic life it could harbor? We've journeyed through the enigma of life, pondering the potential of silicon-based organisms. We've delved into the extremes, contemplating life's resilience in the harshest of environments. All these theories, while speculative, broaden our understanding of what life could be beyond the carbon-based paradigm we're familiar with. Our universe is a cradle of diversity, a tapestry of elements, and a playground of extreme conditions. The potential for life to adapt, evolve, and thrive in such a wide array of environments is immense. It's imperative that we keep an open mind in our cosmic quest. For the universe has a knack for surpassing our wildest imaginations. So next time you gaze up at the stars, remember, the universe might be teeming with life forms that are more exotic than we can even comprehend.